Good morning. Today I am going to teach about database management system. So the outlines are the needs for database, data models, relational databases, database design, storage manager, query processing, and transaction manager. So these are the topics I am going to cover. So first we will know about so what is database management system. Where database in database management system, so database is a collection of data and management system is a set of programs to store and retrieve those data. So based on this, we can define Dbms like this. Dbms is a collection of interrelated data and set of programs to store and access those data in an easy and effective manner. Okay, it contains a collection of interrelated data, set of programs to access the data, and an environment that is both convenient and efficient to use. So why we need DBMSs? So database system are basically developed for large amount of data. When dealing with huge amount of data, there are two things that require optimization here. One is storage of data and retrieval of data. So according to storage of data system, the data is stored in such a way that it requires lot less space as redundant data has been removed before storage. And fast retrieval of data, along with storing the data in an optimized and synthetic manner, it is also important that we retrieve the data quickly when needed. So data systems ensure that the data is retrieved as quickly as possible. And the database applications where we can use is banking applications for transactions and airlines. In airlines, for reservations and schedules. In universities, registrations and grades. And sales, customer, products, purchase. So in online retails like order tracking, customized recommendations, and manufacturing, production, inventory, order, supply chain, and human resources, employee record, salaries, tax deductions. These are the applications we use, database applications. And database can be very large, and the database touches all aspects of our life. So if you take an example, university database, an application program example like a new student, instructor, course. So register student for course and generate class rosters. So we need to assign grades to the students, compute grade point average, and generate transcripts. So in early days, database applications were built directly on top of the file system. So the drawbacks of file system is, first one is data redundancy. So here the data redundancy refers to the duplication of data. So let's say we are managing the data of a college where a student is enrolled for two courses. The same student details in such case will be stored twice, which will take more storage than needed. So data redundancy often leads to higher storage cost and poor access time. So duplicates means redundancy. So an inconsistency. So data redundancy leads to data inconsistency. So let's take the example. A student is enrolled for two courses, and we have student address stored twice. Now let's say student requests to change his address. If the address is changed at one place and not in all the records, then this leads to data inconsistency. It means data redundancy leads to data inconsistency. So duplication may cause a redundancy and inconsistency. So difficulty in accessing data. So need to write a program to carry out each new task. Suppose if we take dependency. So in flat files, if you write each program in one file, different files. So for every file we need to perform a new task. It is very difficult. In data isolation, because data are scattered in various files and files may be in different formats, writing new application programs to retrieve the appropriate data is difficult. And we have integrity problems also. So integrity concerns like become buried in program code rather than being stated explicitly. So hard to add new constraints or change existing ones. So these are the drawbacks of using file system to store the data. And atomicity of updates. So atomicity of a transaction refers to all or nothing, which means either all the operations in the transaction execute or none. So let's take an example. Let's A transfers 100 rupees to B account. So this transaction consists multiple operations such as and debit from A's account, credit to B's account. Like any other device, a computer system can fail. Let's say it fails after first operation. Then that means A's account would have been debited by 100 rupees, but the amount was not credited to the B's account. In such case, the rollback operation should occur to maintain the atomicity of transactions. It is difficult to achieve atomicity in file processing system. Next, concurrent access by multiple users. Where concurrent access needed for performance, so uncontrolled concurrent access can lead to inconsistencies. Suppose example, so two people read a balance 100 and update it by withdrawing a money 50 each at the same time. And security problems. So data should be secured from unauthorized access. For example, a student in a college should not be able to see the payroll details of the teacher. Such kind of security concerns are difficult to apply in the file processing system. Okay, these are the drawbacks. To overcome this, database system offers solutions to all the above problems. So levels of abstraction. So we have physical level, logical level and view level. In physical level, it describes about the record is stored, and in logical level describes data stored inside the database and the relationship among the data. Like in view level, application programs hide details of data types. Views can also hide information for security purposes. These are the levels of abstraction. So the architecture, so view level and logical level and physical level. Instances and schemas. Instances and schemas similar to types and variables in program language. So we have logical schema, physical schema. And in logical schema, the overall logic structure of the database will be there. So take an example, the database consists of information about a set of customers and accounts in a bank and a relationship between them. So analogous to type information of a variance in the program. So in physical schema, the overall physical structure of the database will be there. So instance means the actual content of the database at a particular point of time. And physical data independence means the ability to modify the physical schema without changing the logical schema. So here application depends on the logical schema in general. The interface between the various levels and components should be well defined so that changes in some parts do not seriously influence others.